Hello and welcome to my presentation. I am Hassan Mahach, a PhD student at Cadi University of Morocco. The topic of my presentation is study of the impact of an earth to heat exchanger on the thermal and site conditions of a building in hot semi-arid climate. My presentation outlines as follows. I will start by national energy context, then the principle of the earth to heat exchanger, followed by building description and methodology, and finally results and conclusion. In Morocco, buildings are one of the most energy consuming sectors, with a share of 33% of the total energy consumption, and 51% of electricity consumption is dedicated only to building sector. About one-third of this energy is attributed to the conventional cooling and heating systems. To this end, alternative sustainable solutions should be implemented, including passive and low energy consumption systems. And one of them is the earth to heat exchanger. This system uses the underground as a heat source or sink to heat or to cool the outdoor air. So thanks to the thermal inertia of the soil, the underground temperature is lower than the outdoor one in summer and higher in the winter. So the principle is very simple. Outside air is blown through varied pipes and gets heated or cooled and then used to produce indoor thermal comfort conditions in the building. So we can use it for cooling as well as for heating. But in this work, we are interested in cooling purpose. The building considered is a villa type located in the suburb of Marrakech in Morocco. This building contains many passive and semi-passive systems, and one of them is the earth heat exchanger, which consists of 3 parallel PVC pipes of 72 meter length each and 15 centimeter diameter, buried at 2 to 3 meter depth. And each pipe is equipped with a fan which blows air into the building. The external walls, as well as the first floor terrace and the roof, are well insulated, but also the case of the building without the insulation materials is considered to be studied. The building is composed of 12 zones, 6 in the ground floor and 6 in the first floor, but just 4 zones are considered to be connected to the earth exchanger. 3 of them are located in the ground floor, and the fourth one is located in the first floor. TRNSYS software is used for the simulation using 2 main models, type 56 for the building and the well-validated model type 460 for the earth exchanger. Temperature controls are also used to control the fan operation according to the indoor temperature. The building is considered to be occupied according to these 2 profiles, that in the work days and the weekend, all doors and windows are closed. Our windows are occupied with external aluminum shutters, and the opening of these shutters is managed according to a specific schedule. This figure represents the indoor temperature of living room 1 during the hottest week. So in the case of the no insulated building, the indoor temperature can reach a maximum of 37 and 34 degrees C respectively without and with the earth exchanger. And in the case of the insulated building, the indoor temperature can reach a maximum of 33 and 30 degrees C respectively without and with the earth exchanger. For the second zone, the indoor temperature can reach a maximum of 37 and 32.5 degrees C respectively without and with the earth exchanger. And in the case of the insulated building, the indoor temperature can reach a maximum of 32.5 and 29 degrees C respectively without and with the earth exchanger. Regarding the annual cooling loads, the insulation of the building can reduce the cooling loads of about 46%, and these loads are further reduced of about 13% when the insulated building is connected with an earth exchanger. For the second zone, the insulation of the building can reduce the cooling loads of about 60%, and these loads are further reduced of about 14% when the insulated building is connected with an earth exchanger. So to summarize, from the results presented above, we can conclude that if the insulated building is connected with an earth exchanger, a reduction in the indoor air temperature up to 8 degrees C can be achieved, and a reduction of the annual cooling loads up to 65% can be achieved. So we recommend that the building should be insulated before using the earth exchanger in order to combine the two. Thank you for your attention.